On July 16, 2026, at WIC 26 in Shanghai, Moonshot AI released Kimi K3, a 2.8 trillion parameter mixture of experts model with open weights promised for July 27 under modified MIT. Within 48 hours, demand crushed their GPU infrastructure so hard they had to halt new subscriptions. This isn't another China caught-up story. This is a technical breakdown of what makes Kimi K3 different, how it's built, how you can use it, and why it sold out in 2 days. Kimi K3 is a sparse mixture of experts model. 2.8 trillion total parameters, but only 16 of 896 routed experts activate per token plus shared experts. That means for any single inference pass, you're computing a fraction of the full model. This is how you get frontier-level intelligence without frontier-level compute on every token. The routing is handled by Moonshot's stable, latent Mo system, which balances expert assignment during training to prevent the classic Mo problem, expert collapse, where a few experts get all the traffic and the rest sit idle. Stable latent Mo enforces a fully balanced expert parallel training method with static shapes and no host synchronization. Translation: the training pipeline doesn't bottleneck on coordination overhead between GPUs. At 896 experts, routing and dispatch become first-order engineering problems. Moonshot solved this at scale. The attention mechanism is where K3 separates itself. Standard transformer attention scales quadratically with sequence length at 1 million tokens. That's catastrophic. Moonshot introduced Kimi Delta attention, or KDA, a hybrid linear attention architecture. Instead of computing full attention over every token pair, KDA approximates attention with a linear recurrence that can be computed in constant memory per token, combined with attention residuals, which preserve information from earlier layers that standard linear attention tends to lose. The result is a 75% reduction in KV cache size and a 6.3x speedup in decoding throughput at 1 million token context. That's not incremental. That's the difference between we can technically do 1M context and we can do 1M context in production at usable speed. Most large models are trained in full precision, then quantized after the fact for deployment. This causes quality drops. Kimi K3 flips this. It applies quantization-aware training from the supervised fine-tuning stage onward. Weights are trained in MXFP4, a 4-bit floating point format with activations in MXFP8. This means the model has never seen full precision during fine-tuning. It's been optimized for 4-bit deployment from the start. The result, when you deploy K3, you're running the model as it was actually trained, not a degraded copy. For self-hosting, this matters enormously. MXFP4 weights at 2.8 trillion parameters means roughly 1.4 terabytes of model weights. Still massive, but dramatically smaller than FP16 would require. On the Artificial Analysis Intelligence Index, Kimi K3 scores 57, ranking 3rd out of 189 models, behind only Claude, Fable, 5, and GPT-5.6 Sol. On STWI Bench verified, it hit 76.8 to 80.6% depending on evaluation harness, comparable to frontier closed models that cost 5 to 10 times more. On GPQA, 93.5%, on AIM math problems, 96.2%. It took first place on the front-end code arena, meaning it writes better UI code than anything else tested. But here's the catch, and this matters. On the AA Omniscience benchmark, accuracy improved from 33 to 46% over the previous generation, but the hallucination rate climbed from 39 to 51%. The model is smarter and more confident in its mistakes. This is the trade-off frontier models always face. Capability and hallucination are correlated, not inversely. K3 is not exact. Moonshot offers Kimi K3 in 2 main configurations. K3 Max is the default chat interactions, single-agent tasks, coding, document analysis, research. This is what most users on Kimi.com and the mobile apps interact with. K3 Swarm Max is for large-scale parallel multi-agent workloads, think distributed reasoning across many agents simultaneously. The API costs $3 per million input tokens and $15 per million output. Cached input drops to 30 cents per million. Compare that to Claude Opus 4.8 at $5 input, $25 output, or GPT 5.6 Sol at $5 input, $30 output. K3 is roughly half the price of its direct competitors. Moonshot also ships Kimi Code AI, a terminal-based coding agent that runs K3 locally as an autonomous developer tool. Think of it as Claude code, but running on an open weight model you can eventually self-host. When the weights drop July 27th, here's what you need to run the full model. Approximately 3 terabytes of VRAM, that's about 32 H200 GPUs or 16 B200s. No single GPU can hold this model. This is a data center cluster problem. You need distributed inference across multiple nodes with high bandwidth interconnect. VLLM is building production scale support with Mo-specific optimizations for the 896 expert routing. For most developers, the practical path is the API, not self-hosting. But for enterprises with data sovereignty requirements, the open weights under modified MIT mean you can run this model entirely on your own infrastructure with no per token cost. The break-even point against API pricing is roughly 300 million tokens per month of sustained usage. Below that, use the API. Above it, buy the GPUs. 2 days after launch, Moonshot paused all new subscriptions. Their official account announced that surging usage had pushed GPU resources to near capacity. Existing users were prioritized. The compute crunch highlights a reality of frontier AI that gets lost in the benchmark headlines. A model is only as useful as the infrastructure behind it. Moonshot built a frontier model, but they couldn't serve it to everyone who wanted access. This is the same problem OpenAI and Anthropic faced during launches, but Moonshot is a startup with a fraction of their compute budget. The sellout also reveals demand signal. People weren't just curious, they were building on it immediately. The API was cheaper than alternatives, the quality was competitive, and developers migrated fast. When the open weights land July 27, expect another compute crunch, this time on the download side, as teams mirror the model across Hugging Face and regional servers. 3 takeaways for anyone building on AI. First, KDA changes the long context economics. If linear attention with residuals delivers 6x decoding speedup at 1 million tokens, the cost of long context inference drops dramatically. Any application doing document analysis, code-based reasoning, or multi-turn agent workflows benefits. Second, MXFP4 quantization-aware training is a signal. More models will train in low precision from the start, not quantize afterward. This makes deployment cheaper and quality more predictable. Third, the 896 expert Mo at this scale proves that sparse architectures scale further than dense models at the same parameter count. The future of Frontier isn't bigger dense models, it's more experts, better routing, and sparser activation. Kimi K3 is a proof point for that thesis. The weights drop in days, watch the mirrors.